Tonight, you are going to light speed. Not to break a record, not to wave at passing stars, not even to prove that human engineering has finally defeated distance. You are simply trying to find out what space and time do to you before they stop agreeing with Earth. You are a human passenger inside a ship that can keep accelerating long after every ordinary spacecraft would have failed. Its walls hold pressure. Its field coils keep the cabin from becoming an oven. Its clock is synchronized for the last uncomplicated moment of your life with the clocks on Earth. Outside the window, the solar system still looks like a neighborhood. Inside the cabin, you still trust ordinary verbs. Travel, wait, watch, arrive. But what happens when the distance in front of you no longer behaves like distance? What happens when the time on Earth no longer keeps pace with the time on your wrist? Do the stars pile up ahead of you, or thin out and run? Does the universe become brighter, deadlier, stranger? If you could actually touch light speed, would time stop for you, or would the question itself stop making sense? And if the ship survives every engineering problem, can space and time themselves become the final hazard? The engines stay on. You survived the acceleration. Now speed itself becomes the first problem. At first, the change feels almost insulting. Nothing explodes. The hull does not scream. The stars do not streak past your window like scratches in a film. Space is too empty, and your body is too local for speed alone to announce itself theatrically. If you were expecting the universe to behave like a tunnel with white lines whipping by, the universe declines. Your coffee still drifts toward your mouth if you are careless. The indicator lights still blink with the same patient rhythm. The cabin remains a room. The betrayal begins in the numbers. Every increase in speed makes the next increase harder. In ordinary life, double the push and you expect something like double the result. Near light speed, the bill keeps arriving after the thrill is gone. The more closely your velocity approaches the speed of light, the more stubborn the remaining fraction becomes. You can reach 90% of light speed in this thought experiment, then 99, then 99.9. Each success sounds like an ending and behaves like a preface. The final gap never quite closes. That is the first honest answer hiding inside the title. For any ship with mass, reaching the speed of light is not the last difficult step. It is the forbidden one. According to special relativity, light speed is not a milestone waiting at the end of a long enough acceleration. It is a boundary built into the way spacetime relates motion, energy, and measurement. Massless things, like light in vacuum, move at that speed. Massive things can approach it, borrow more and more of its strange consequences, and make every clock and ruler around them disagree in increasingly dramatic ways. But they do not simply cross onto the same terms. So the mission changes. You are no longer asking what a realistic ship would do at exactly light speed, because relativity does not hand massive travelers that option. You are asking the only version that physics allows. What happens as you get so close to light speed that ordinary intuitions become useless? The first answer is time. Not time as a mood, not time as the dramatic statement that your life flashes before your eyes. Time as measured duration between events. Time as the rate at which clocks accumulate moments. Time as the difference between how long a journey lasts for you and how long that same journey lasts for everyone watching from the system you left behind. Your ship carries atomic clocks. Earth carries atomic clocks. No one has to guess. If your ship races away at a large fraction of light speed, people on Earth will measure your clock running slower than theirs. From their perspective, the processes inside your cabin stretch out. Your speech, your pulse, your maintenance routines, the slow aging of your skin, all continue normally to you, but not to the distant observers who compare your clock to theirs. This is not because your mechanism is broken. It is because motion changes the way different observers slice space-time into before, after, here, and now. Inside the cabin, nothing about your own body feels slowed. That is the second betrayal. Time dilation does not feel like syrup. Your heart does not complain that relativity has altered its contract. You still count 1 second per second. You breathe on schedule. You finish sentences at human speed. A moving clock always looks normal to the person carrying it because proper time, the time along your own path, is the only time your nerves can experience directly. The strangeness appears only in comparison. Suppose Earth sends a regular pulse once every hour by its own clocks, and your ship returns one by its own. The pattern refuses to line up. Their messages grow more widely separated according to you. Yours grow more widely separated according to them. Some of that is the simple stretching caused by increasing distance, but beneath that, communication delay sits the deeper effect. The intervals attached to your motion are not being organized by one shared universal clock. There is no cosmic wall clock above the ship and the planet keeping impartial score. Relativity dismisses that comforting idea early. You feel this first, not as mathematics, but as the death of conversation. Messages from Earth begin by arriving late enough to feel inconvenient, then late enough to feel ceremonial, then late enough to feel historical. A reply stops being an answer and becomes an artifact from a version of home that no longer exists by the time you hear it. You can still exchange information. You can still compare clocks. What you cannot preserve is the ordinary rhythm in which two people inhabit one living present together. Relativity does not merely tax the schedule. It changes the meaning of shared time across distance. And if the ship ever turns around, the situation becomes stranger in a way that finally refuses to stay philosophical. People often hear that Earth sees your clock running slow, and you see Earth's clock running slow, and they assume the story must end in a draw. You are the one who leaves, accelerates, changes frame, and comes back. During the turnaround, the set of distant events that your frame counts as simultaneous changes with you. The disagreement about now that seemed abstract becomes the hinge of the reunion. When your ship and Earth meet again, the clocks do not compare impressions. They compare accumulated time, and one path can genuinely contain fewer lived years than the other. That is why relativity is not just a trick of appearances. It can survive the handshake at the end of the mission. This is usually the moment people reach for the phrase time travel, and the phrase is both useful and dangerous. Useful, because if you travel near light speed and later return, less time can pass for you than for the people who stayed behind. Dangerous, because it sounds like a magical device rather than a geometric consequence. You are not jumping outside time. You are taking a different path through space-time, one whose accumulated proper time can be shorter than Earth's between departure and reunion. That means speed does not merely affect how fast you move through space, it affects how much future you personally collect on the way. At 90% of light speed, the effect is strong. At 99%, it becomes hard to ignore. At still more extreme fractions, the discrepancy becomes the architecture of the whole mission. A voyage that devours decades on Earth can consume far less time aboard the ship. From your perspective, the future of the civilization that launched you begins to lean toward you. Not because Earth is rushing to meet you in any ordinary sense, but because your route through space-time is carving away more of the elapsed time you expected to pay. Time, then, does not stop as you approach light speed. It separates. Your time and Earth's time stop pretending to be the same thing counted on different clocks. They become different measured lengths between the same broad milestones, and once time stops behaving like a shared current, space follows. Distance sounds solid until relativity gets involved. On the launch pad, someone can point to a target star and tell you how far away it is. The statement feels objective. So many light years, so many kilometers, so much empty black to cross. But distance in relativity is not a permanent label glued to the universe. It depends on which events you count as simultaneous when you measure the endpoints. For Earth, the destination may be 4 light-years away. For you, once the ship is moving at a sufficiently high fraction of light speed, the distance measured in your frame along the direction of travel shrinks. This is length contraction. It does not mean the star itself has been physically crushed like paper in your hands. It means the spatial interval between where you are now and where the star is right now, according to your frame's definition of right now, becomes smaller than the value assigned in Earth's frame. This is one of the rare ideas in physics that sounds like a cheat and is not one. If time dilation means your ship can cross years of Earth's calendar while aging less, length contraction explains the same story from your side. You do not say, "I got there quickly because I stole hours from my body." You say, "I got there quickly because the journey ahead was measured as shorter in my frame." Both descriptions belong to the same relativistic geometry. Neither is the secret truth hiding behind the other. This is what makes relativistic travel emotionally double-edged. The stars become more reachable for you by becoming less shared with the civilization that launched you. Your trip gets shorter in your frame at the same moment Earth's history gets longer without you. Now the cabin window starts lying in a more useful way. The stars ahead do not merely stay stars. Their light is squeezed toward higher energies. Visible starlight can shift bluer. Far enough into the thought experiment, radiation that began harmlessly can march up the electromagnetic ladder. Light from behind is stretched the other way, reddened and dimmed. Meanwhile, the sky itself crowds forward. Directions that once felt wide apart begin to bunch into the region ahead of your motion. The universe does not look evenly distributed around you anymore. It gathers in front like weather. This is where speed stops being only an abstract victory and becomes an environmental hazard. At everyday velocities, space is mostly emptiness. Near light speed, emptiness becomes busy. The thin gas between stars, the dust grains that would normally be minor concerns over astronomical distances, the background light that fills the universe, all gain new significance because relative motion changes the energy of what hits you. A single grain of dust is still small. At relativistic speed, small no longer means gentle. Shielding becomes less like armor against random debris and more like a treaty with kinetic energy that you are unlikely to win forever. Inside the ship, that changes the meaning of navigation. At slow speed, course correction is mostly about accuracy. Near light speed, course correction is also about which part of the hull must face the worst of the universe. The nose of the vessel stops being merely the front. It becomes the place where your motion asks the vacuum to reveal its sharpest version. Even the microwave glow left over from the early universe, usually cold and faint, does not remain visually and energetically innocent if you imagine pushing close enough to light speed. Motion shifts what frequencies arrive and from which directions they dominate. The dark between stars becomes less passive. It begins participating. So what happens to space? Space stops feeling like a stage and starts behaving like a compressed, directional field of consequences. Forward distance contracts. The sky aberrates toward the nose of the ship. Incoming light changes color and energy. The vacuum ahead becomes a denser conversation with radiation and particles than the same vacuum would be for a slower traveler. You are not merely covering space faster. Your motion is changing how the structure of space is measured and how the contents of space strike you. And what happens to time? Time stops serving as a universal background and becomes personal, path-dependent, and irreversible in a new way. Earth and ship no longer agree about durations between shared milestones. Simultaneity itself fractures. The question, what is happening on Earth right now, quietly loses its innocence. Because your definition of now no longer matches Earth's, there is no single corrected answer hidden behind the dispute. Now, at interstellar relativistic speed becomes frame-bound, not globally owned. That is the part most people hear once and never quite forgive. On Earth, simultaneity feels effortless. The sun is setting here. A city is waking there. A signal left the moon a little over a second ago. You can live your entire life with the intuition that although information takes time to travel, there is still one underlying present being revealed imperfectly. Special relativity removes that privilege. Different observers in relative motion carve spacetime into different sets of simultaneous events. When you change velocity, the slice you call present changes too. That can sound bloodless, until you picture it happening behind you. Earth is still turning. Weather is still crossing oceans. Someone is still waiting for news of your ship. But the set of Earth events your current frame treats as happening right now is not the same set it treated that way before your last major change in velocity. The universe behind you has not lurched because you fired an engine. What changed is the way space-time lets you coordinate distant events into one present account. This does not mean reality becomes subjective in the lazy sense. It means reality is four-dimensional enough that different observers can make equally valid, internally consistent measurements without sharing a single, universal present. Events and intervals remain real. The old expectation that everyone should be able to sort distant events into one common now does not survive. Imagine receiving a message from Earth that says your sister looked up at the sky at this moment. That phrase worked when both of you were living inside roughly the same speeds and gravitational conditions. Near light speed, it is no longer a simple sentence. Her now and your now are separated not just by distance and signal delay, but by the relativity of simultaneity itself. Your ship can keep a log. Earth can keep a log. Reuniting those logs into a single intuitive timeline is the hard part, not the easy one. This is why exact light speed becomes less a destination than a collapse point for ordinary language. As you approach light speed, the relativistic factors governing time dilation and length contraction grow without bound. The energy required to keep adding speed does the same. For a massive traveler, the limit is telling you that the framework of a person rides a ship up to light speed and then reports what it feels like there is built on a contradiction. There is no rest frame for light in special relativity. You cannot consistently ask what a photon experiences along its journey the way you ask what an astronaut experiences along hers. Proper time along a light-like path is not the same kind of personal duration that your body carries. The question breaks before the traveler does. That failure is not a flaw in the theory. It is the theory telling you exactly where everyday intuition has reached past its jurisdiction. Roads, aircraft, and even ordinary rockets tempt you to imagine that faster travel is always just more of the same. Relativity draws a line and says that beyond a certain point, the words themselves need new care. The passenger's time, the route's length, the meaning of simultaneity, even the idea of asking for a traveler's experience at the boundary, all have to be re-examined before the story can continue. So if you insist on the exact phrase, if we could reach light speed, what would happen to space and time? The most faithful answer is this. For a massive human traveler, the attempt drives time dilation, length contraction, relativistic aberration, and energy demands toward extremes. But the exact endpoint is not a place the traveler can inhabit. Space and time would not simply look weird there. Your usual way of defining there would fail. But that is not a disappointing answer. It is the real payoff, because the closer you get to the boundary, the more the universe reveals what it has been doing all along. Space and time were never separate containers, one for where things happen and one for when they happen. They were always coordinates inside a single structure that motion forces you to notice. At low speeds, the structure is merciful. It lets human intuition pretend that time is absolute, distance is universal, and the present is shared. Near light speed, mercy ends. The ship teaches you this in layers, first by making Earth's clocks drift away from yours, then by shortening the road ahead without moving the destination by magic, then by turning darkness into radiation, direction into energy, and now into a local privilege rather than a universal fact. The further you press toward light speed, the less the universe resembles a map with neutral units, and the more it resembles a negotiation between geometry and causality. And causality is the silent rule you have been depending on the whole time. Relativity does not scramble cause and effect just to be theatrical. In fact, one reason the speed of light matters so much is that it helps preserve the causal order that keeps physics coherent. Signals, influences, warnings, rescues, commands, confessions, all the meaningful ways one event can shape another must respect that structure. Light speed is not merely fast, it is woven into how spacetime protects the order of events from becoming nonsense. That is why the boundary is so expensive. Not because the universe dislikes ambition, but because the boundary is part of the grammar. If your ship could somehow keep pushing forever, what you would experience would not be time freezing around you or stars politely stretching into movie streaks. You would experience your own cabin normally, while the relationship between your measurements and Earth's became more and more extreme. The distance ahead would continue to contract in your frame. External clocks would continue to diverge from yours. Radiation and particle impacts would continue growing more severe in the forward direction. The cost of the last fraction of speed would continue exploding. The universe would keep answering the same way. Closer, stranger, harsher, but not crossed. That is the delayed thesis the whole journey has been building toward. Near light speed, the universe does not decide whether space matters more than time or time matters more than space. It withdraws the right to separate them cleanly. The shortened route, the slower distant clocks, the altered sky, the dangerous forward radiation, the disagreement about what counts as now. These are not separate weird tricks. They are one structure showing its different faces. To understand why the boundary feels so severe, you have to spend more time inside the ship and less time inside the slogan. "Nothing can go faster than light" is a sentence most people meet early, memorize quickly, and imagine they understand. But the sentence is too polished. It sounds like a speed limit sign posted on some cosmic highway. It sounds like the universe first created ordinary motion, then later decided to impose a rule for safety. What relativity actually offers is stranger and more intimate. Light speed is not just a policy, it is built into the geometry that tells observers how to compare clocks, rulers, signals, and causes. The ship is not racing toward a line painted on nature. The ship is trying to move through a geometry that changes the meaning of measurement as your speed rises. This is why every naive fantasy about the journey begins by failing in the wrong place. You might imagine that the hard part would be a crushing force on your body, some giant hand pressing you into the chair more and more severely until relativity itself becomes physical pain. That could certainly happen if you accelerated too violently. But the physics of high speed and the biology of high acceleration are not the same problem. A ship could, in principle, accelerate gently for a long time. Your body might tolerate the ride better than your intuitions do. The cabin could feel almost humane while the external consequences become less and less humane by the hour. This is one of the essential emotional tricks of relativity. Locally, your body can feel normal, while globally, your relationship to the universe becomes bizarre. So imagine the ship is kind to you on the inside. The couch supports your back. The recycled air is steady. Water moves through plumbing instead of floating away. If the designers are generous, the cabin may even simulate a little gravity through thrust or rotation, enough to keep your bones and muscles from forgetting the conditions that shaped them on Earth. You eat, sleep, stretch, check systems, listen to delayed messages, and watch the instrument panels tell the story more honestly than the window can. The interior remains comprehensible because local physics remains local. Your coffee does not become relativistic coffee. Your spoon does not contract in your hand. Your heartbeat does not wait for a lecture on Lorentz transformations before keeping time. That normalcy is not a contradiction. It is the reason relativity needs comparison. Every profound effect in this story is relational. your body compared with Earth's calendar, your ruler compared with Earth's ruler, your present compared with Earth's present. A ship approaching light speed is not a place where everyday physics stops working. It is a place where everyday physics refuses to extend globally without correction. Inside the cabin, you remain the center of one valid frame. Outside the cabin, the universe stops agreeing to summarize itself from everyone else's point of view at once. This matters for another reason. It means you cannot learn the deepest part of the lesson by staring only at your own hands. Imagine you sealed yourself in a perfect compartment with no windows and no communication with the outside. Once the engine stopped and you drifted smoothly, there would be no local experiment inside that compartment that could reveal an absolute velocity. That is an old but still startling principle. Motion at constant speed is not something you feel directly as motion through an absolute medium. You feel acceleration. You feel vibration. You feel impacts. But uniform relativistic travel through empty space is not a wind against the skin of the soul. It is a state whose weirdness appears when frames compare their accounts. So much of the story depends on signals, because signals are how worlds argue. When Earth and ship exchange light pulses, each pulse becomes more than a message. It becomes an attempt to compare histories. Every received interval, every stretched timestamp, every frequency shift is part of the evidence that space and time are not behaving as one shared grid. The communication problem is not merely practical, it is philosophical in the most material sense. You are learning what the universe permits one observer to know about another observer's rate of becoming. Suppose the crew decides to make the experiment personal. Before launch, you and someone you love on Earth agree to a ritual, one message every day. No matter how delayed or garbled the future becomes, you will each send a note stamped with your own local date and the smallest truthful description of your day. At first, the exchange is sentimental, then it becomes diagnostic. Then it becomes devastating. You do not simply watch relativity on a chart, you watch one relationship stop inhabiting one timeline. Your messages still touch, they no longer meet. This is when the phrase, aging more slowly, reveals both its truth and its cruelty. Popular descriptions often make time dilation sound like a prize. You go fast, therefore you remain younger. In the most literal comparative sense, yes, less proper time can pass for you than for those who stayed behind. But youth is not something you own in isolation. It means something only against the changes others experience with you or without you. A relativistic journey does not give you extra life in the ordinary human sense. It redistributes whose future you get to share. The bargain is not immortality, it is asymmetry. There is a reason so many thought experiments about near-light travel quietly become stories about separation. Distance already isolates. Relativity refines the isolation into different rates of existence. If you travel out and back while Earth continues on its slower-moving world line, reunion becomes a confrontation with stolen simultaneity. Friends may be older than the version of them you were emotionally prepared to meet. Institutions may have changed purpose. Languages may have drifted. The city you return to may not feel like the same city, not because you physically skipped its history in a magical jump, but because your path through space-time collected less of it than the planets did. And all of this is before we return to the outward appearance of the sky. The sky matters because humans still trust vision more than abstraction. We want the universe to prove its strangeness in a scene. Near light speed, it eventually does. The forward direction compresses. Light from ahead is blue shifted. Light from behind is red shifted. Angles distort. Sources crowd toward the direction you are moving. The cosmos seems to gather in front and loosen behind, as though space has developed an opinion about your destination. But even here, care matters. The exact appearance depends on your speed, your environment, and what wavelengths your eyes or instruments can register. Much of what becomes important near relativistic travel would be more instrumentally dramatic than visually cinematic. Radiation you would never have called visible can shift into dangerous bands. Background fields can become operational problems long before they become beautiful ones. The universe may look stranger, yes, but it also becomes less honest to unaided human senses. You increasingly need detectors to tell you which part of the sky is not merely bright but lethal. That is another pattern the journey keeps repeating. What looks cinematic often matters less than what matters instrumentally. For example, people love the image of starlight streaking into lines. It belongs to animation, to science fiction windows. Real interstellar motion through sparse space does not provide that kind of roadside blur, because stars are too far apart and relative angular change is not a tunnel effect. What matters far more is that the energy and direction of incoming radiation change in your frame. The danger is not that the stars finally look fast. The danger is that the environment stops being as forgiving as its apparent emptiness suggested. Now, imagine the engineers who built this vessel trying to prepare for that. They cannot design only for thrust and life support. They have to design for a changed sky. Shielding is no longer simply a layer protecting you from generic space hazards. It has to face a directionally transformed environment. The front of the ship becomes morally different from the back. The geometry of tanks, habitats, storage mass, and sacrificial layers matters, because the world ahead is not just far, it is increasingly energetic in your frame. You begin to understand why any realistic near-light mission would be as much about what you carry in front of yourself as how hard you can push from behind. A starship at modest speed might talk about efficiency the way an aircraft does. A starship at relativistic speed has to talk about efficiency and survivability as one subject. How much mass can you devote to shielding before the extra mass makes acceleration vastly more expensive? How little shielding can you tolerate before a rare impact stops being rare enough? How do you protect delicate instruments from a universe you are effectively ramming at extraordinary relative energy? How do you keep the thing that makes travel possible from making arrival irrelevant? This last question returns us to a deeper emotional theme in the script. Every solution near light speed becomes a new problem in a different accent. More thrust means more energy and engineering cost. More shielding means more mass to accelerate. More time spent accelerating means greater relativistic effects and more accumulated exposure to a transformed environment. More ambition in your route means less shared time with home. Every attempt to master distance reappears as a negotiation with time, matter, and cause. The ship is not just fighting one enemy, it is moving into a region where categories that feel separate on Earth begin acting like accomplices. Even navigation itself changes character. At slow interplanetary speeds, navigation is already an exercise in prediction. Targets move. Gravity nudges trajectories. Delays force autonomy. But at relativistic fractions of light speed, aiming becomes entangled with future motion on scales that humble ordinary intuition. A destination star is not sitting still waiting for your dramatic arrival. Planets orbit. Systems move through the galaxy. The image you have of the target is always old, because light takes time to reach you. The faster you move, the less forgiving your mistakes become. A tiny angular error early in the mission can bloom into an astronomical miss later. And then there is the question nobody asks first, but every mission eventually has to. What counts as arrival? This sounds innocent, until relativistic speed ruins its innocence the way it ruins everything else's. If you pass through a target system at an enormous fraction of light speed without the ability to slow down, have you arrived? Or have you merely survived the longest possible flyby? If your instruments collect a flood of data in a brief, violent crossing and then vanish into deeper dark, is that success? If humans are aboard, can any mission be called an arrival if the speed of encounter makes local operations impossible? Suddenly, not only space and time, but victory itself becomes frame-sensitive in spirit, if not in formal definition. You cannot treat braking as a footnote. On Earth, travel stories are usually told from departure. In relativistic travel, Deceleration is half the philosophy. Speed can shorten the route in your frame, but too much speed can also strip your destination of usefulness. A probe may tolerate that. A human mission may not. To live anywhere, study anything carefully, or even choose a direction inside the new system, you need not only to reach the place but to stop being a relativistic projectile inside it. The same velocity that made the journey possible can make the destination inaccessible in practice. This is one of the cleanest examples of the ship's central paradox. Speed is solution and sabotage at once. That paradox is not dramatic decoration. It flows from the same physics that made the opening promise work. The universe allows you to trade shared time for subjective progress, but it does not promise that subjective progress ends in useful presence. If you cannot manage the energy cost, the shielding, the aim, and the braking, near-light travel becomes less a voyage and more a magnificent refusal to remain where you began. Now return to the human body for a moment, because it has been waiting patiently for its humiliation. You are clever. Your species can derive Lorentz factors, design clocks, build detectors, model plasmas, map trajectories. None of that changes the fact that your nervous system evolved at walking speed under one gravity well, beneath an atmosphere that softens radiation and stabilizes temperature. Every truly relativistic effect is, in a sense, a reminder that your intuitions were built for a provincial neighborhood. This does not diminish you. It simply means that the voyage is not only across distance, it is across the scale at which your inherited common sense remains trustworthy. That inherited common sense keeps asking the wrong questions. Will time stop? What will I see out the window? Can I outrun my own light? Will the stars smear? Each question contains a tiny wish that the universe might explain itself theatrically and personally. Relativity answers more coldly and more beautifully. Time does not stop for you. Your own clock continues normally. What changes is the comparison between your time and someone else's. You do not outrun light locally. Light remains light in vacuum. The stars may not perform for your eyes, but the measurable structure of the world absolutely changes. The lesson is not that reality withholds spectacle. It is that its deepest spectacle is relational. This is why the speed of light is so entangled with causality. If cause and effect are to remain consistent across frames, if one observer's future cannot become another observer's usable past in a way that shatters coherence, then the structure linking space and time must constrain how influence travels. Light speed emerges not as a random number nature picked from a hat, but as part of the conversion factor between spatial and temporal intervals in relativity. When you push against that boundary, you are not merely challenging a speed, you are challenging the consistency conditions that let the universe tell one non-contradictory story at all. Think about what a rescue means. On Earth, rescue is often a matter of distance, weather, logistics, and luck. In deep space, it is already harder. Near light speed, it acquires a conceptual cruelty. If something fails far from home while your mission depends on relativistic motion, there is no simple way for a slower civilization behind you to intervene. Messages arrive late. Hardware cannot catch up trivially. Your frame and theirs disagree about durations and presence. Rescue becomes not merely improbable, but structurally mismatched to the voyage's premise. The faster and farther you go in this mode, the more self-contained your fate becomes. That makes maintenance feel different, too. On a ship moving slowly enough to imagine external help, every repair is partly a bridge to assistance. On a relativistic ship, every repair is a negotiation with isolation. Replace a failed component and you are not just fixing a machine. You are preserving a private world line from becoming a sealed obituary. The dignity of routine work grows. Seals, pumps, radiation monitors, thermal control, guidance systems, computational redundancy, all the unromantic organs of a ship become more morally important than the grand rhetoric of exploration that launched them. And because this is a human story, Boredom becomes a serious character as well. We speak of interstellar travel as if the main difficulty were drama, impacts, failures, equations, thresholds. But most long journeys are made not of climaxes but of repetition. Near light speed does not abolish monotony. It reframes it. Between the rare moments when relativistic consequences become obvious, you still live in a habitat. You still clean surfaces, inventory supplies, exercise, check readings, sleep badly some nights, miss textures Earth gave you for free. The ship may be racing through a region where clocks and rulers disagree violently with home, but inside the cabin Tuesday can still feel like Tuesday. This combination is almost unbearable to imagine clearly. Cosmic strangeness outside, domestic repetition inside. Your life becomes a braid of the most provincial routine and the most unprovincial physics. You wash a cup while your civilization's future ages away faster than your own. You secure a storage bin while forward radiation grows less forgiving. You argue about maintenance schedules, while simultaneity itself refuses to stay shared. Relativity does not replace ordinary living. It traps ordinary living inside extraordinary comparison. At some point, the crew may try to protect itself emotionally by reducing the universe to procedure. This is not cowardice. It is survival. Procedures turn overwhelming truths into next actions. Check the clock drift. Confirm the communication schedule. Verify shielding orientation. Compare background readings. Update navigation. Sleep. Eat. Exercise. Repeat. Humans cannot metabolize the full philosophical content of relativity every morning before breakfast, so the mission becomes a discipline of narrowing attention. That narrowing is one of the few ways to keep the large truth from crushing the small tasks that still keep you alive. But the large truth returns whenever you look back. Earth behind you is not simply a receding dot, it is a receding shared present. Every increase in relativistic separation makes back home less a place you can rejoin unchanged and more a branch of history you have chosen not to inhabit at the same rate. Even if the transmission equipment works perfectly, even if the ship stays healthy, even if the route remains true, the mission is still consuming common life. This is where some people pivot and say the journey would never be worth it. That is not a scientific objection. It is a human valuation, and it deserves respect. Physics can tell you what near-light travel does to clocks and distances. It cannot decide for you whether compressing your experienced travel time while expanding the history you lose with everyone else counts as victory. Some futures would call it heroism. Some would call it exile with good public relations. The equations do not settle that dispute. They only make sure the dispute is honest. Now imagine that instead of a human crew, you send only instruments. Immediately, some parts of the problem relax. A probe can tolerate accelerations, isolation, and encounter speeds that would be unacceptable for a body made of organs and grief. It does not mind if arrival is a flyby, provided the data return is meaningful. It does not experience loneliness when communication becomes archaeological. It is an excellent witness to relativistic geometry because it pays fewer emotional prices for the privilege. But even a probe cannot negotiate with the boundary indefinitely. It still has mass. It still faces shielding problems. It still must aim, survive, impact, manage energy, and somehow report what it finds. The same physics that humiliates a human mission humbles a robotic one, just more efficiently. This comparison matters because it shows that the impossibility of exact light-speed travel for massive objects is not a human weakness. It is a structural statement. Human fragility makes the threshold feel harsher. It does not create the threshold. There is another misconception waiting here, and it has to do with the phrase mass increases. Popular explanations often say that as an object moves faster, its mass increases, and that is why reaching light speed becomes impossible. That language was once common, but it can mislead more than it helps. A cleaner modern explanation is that the energy and momentum needed to continue pushing a massive object upward in speed grow without bound as you approach light speed. The object's invariant mass does not need to change for the limit to become absolute in practice. The important point is not a magical swelling of substance. It is the structure of relativistic dynamics. This is one place where precision protects wonder. If the story is told sloppily, relativity sounds like a carnival booth where objects get heavier and clocks get lazy and rulers panic. Told carefully, it becomes more astonishing. Nothing inside your local frame has to become mystical. The equations remain consistent. The measures remain real. The impossibility arises not from theatrical distortion but from coherence maintained under extreme comparison. The universe is not improvising tricks as you speed up. It is remaining faithful to its own deep bookkeeping, and bookkeeping, on a voyage like this, becomes sacred. The ship's records are more than logs. They are the thread tying one frame's experience to another's. Departure times, received signals, transmitted signals, clock comparisons, environmental readings, trajectory updates, radiation exposures, maintenance events. All of it matters because the mission is not only about getting somewhere. It is about preserving a reconstructible history across non-shared durations. Without disciplined records, relativity would not merely isolate you, it would make later understanding of your isolation much harder. Imagine historians centuries later opening those records. Perhaps they do so on a changed Earth. Perhaps the ship never returned. Perhaps the mission survives only as a library of outbound timestamps and delayed replies from home. The logs would show more than engineering. They would show a civilization testing whether spacetime could be crossed without surrendering narrative continuity. Every discrepancy in the clocks would be part of the evidence. Every gap between message and reply would mark not simply distance but altered coexistence. And that word, coexistence, may be the cleanest way to understand what near-light travel threatens. You can remain causally connected to home through signals while losing the simpler form of living at the same rate. You still belong to the same universe. You stop belonging to the same immediate present. Relativity does not exile you from reality. It exiles you from uncomplicated togetherness. No wonder science fiction keeps reaching for cryosleep, wormholes, or faster-than-light fantasies. They are often emotional technologies as much as transportation technologies. They promise not just speed but relief from the human cost of relativity. Cryosleep says, perhaps we can endure the years by not feeling them. Wormholes say, perhaps we can keep far places without paying with divergent time. Faster-than-light ideas say, perhaps causality can bend without breaking our favorite relationships. Whether any of those promises are physically available is a separate question. Their popularity reveals what people most want delivered from the relativistic bargain. But if the bargain cannot be escaped, then understanding it becomes a kind of maturity. And maturity is what the rest of the mission demands. Suppose the crew presses onward anyway. Not because the cost is invisible, but because the value of knowledge, survival, or destination still outweighs it. The ship climbs deeper into the regime where Earth time and ship time refuse to rhyme. The forward sky remains the dangerous direction. The route ahead keeps contracting in your frame. Communication grows more archival. Every routine aboard becomes an act of faith that the transformed geometry still contains a livable path. Then one day, you face the turnaround. Turnaround is where abstraction becomes drama even for people who thought they already understood the theory. While coasting outward at one relativistic velocity, your frame assigns one set of distant events as simultaneous with your present. Change velocity significantly, and that assignment changes. The effect is not that Earth physically leaps forward in your local cabin like a movie skipping reels. The effect is that the coordinate account by which you relate your now to Earth's distant events has to be redrawn. The math is formal. The intuition feels like betrayal. It is almost impossible not to narrate this badly. If you say Earth jumps into the future during turnaround, you risk sounding like a magician describing a trick. If you avoid vivid language altogether, you risk hiding the real shock. The careful version is this. Because simultaneity is frame-dependent, a major change in your state of motion changes which distant Earth events. Your new frame counts as simultaneous with your current shipboard moment. The universe does not physically lurch to accommodate you. Your bookkeeping of distant time does. Yet when reunion eventually occurs, the accumulated discrepancy in elapsed time is not bookkeeping fiction. It can be measured on real clocks. That is why turnaround feels like the emotional center of the whole thought experiment. Departure taught you that clocks diverge. Turnaround teaches you that the notion of one distant present was never quietly waiting to rescue common sense. Return teaches you that the divergence was not a misunderstanding. It was the geometry speaking clearly all along. By now, perhaps, you can feel the answer to the title question becoming less sensational and more total. It stops being one neutral distance shared by all observers and becomes frame-dependent, contractible, directional, operationally dangerous, and visually distorted under extreme motion. What happens to time? It stops being one universal current and becomes path-dependent, comparison-based, and inseparable from how motion organizes simultaneity and causality. You become the local carrier of one valid account among several, unable to make your experience universal without lying. There is a certain humility in that last point. Human beings like to imagine that seeing something firsthand grants final authority. In many ordinary situations it does. If you touch the stove, you know it was hot. If you cross the room, you know how long it took you. But relativity teaches that first-hand experience, while real, is not sovereign over all other frames. Your own cabin time is true for you. Earth's longer elapsed duration can also be true. Your shortened route can be true. Earth's longer distance can be true. Reality is not wounded by holding both because reality was never obligated to flatter one observer into universality. That is a profound correction not only to physics but to ego, and maybe that is part of why near-light travel attracts people. It promises the fantasy of ultimate speed, but it delivers the education of ultimate perspective. Push hard enough against the structure of space-time, and you do not become its master. You become a student who finally sees the hidden grammar that had been supporting every ordinary day without announcement. Now let us stay with the ship a little longer, because there is one more cost often missed in simplified explanations. Thermal management. Even without invoking speculative propulsion details, any realistic high-energy journey confronts the problem that power, shielding interactions, onboard systems, and external particle impacts all connect to heat. Heat is not simply an engineering nuisance. In vacuum, shedding it is already a design problem, because you radiate rather than convect it away into surrounding air. A relativistic mission must survive not just the romance of speed, but the accounting of waste energy. The ship has to keep you alive while handling an environment and an internal budget far less forgiving than the clean diagrams in popular explanations suggest. Again, the pattern repeats. The glamorous concept cashes out in maintenance language. This does not make the voyage less grand. It makes the grandeur honest. The universe is not defeated by visionary nouns alone. It yields, if it yields at all, to the unglamorous accumulation of workable details. Every leak prevented, every watt accounted for, every sensor cross-checked, every redundancy justified, every gram of shielding placed with intention, every course update reviewed against delayed information. All of it belongs to the meaning of near-light travel as much as the headline theorem does. You may have noticed something by now. The more seriously you take the mission, the less the story sounds like speed and the more it sounds like translation. You are translating between frames, between local experience and distant measurement, between human expectation and relativistic structure. Between the intuitive and the true, even the final answer has to be translated carefully, because the raw sentence, space contracts and time slows down, is both useful and dangerously incomplete. Time dilates in comparisons between frames. Your own lived time does not feel slowed. The destination is not objectively squeezed in every sense for every observer. Precision is not pedantry here. It is mercy toward meaning. Without that mercy, bad metaphors creep in. People start imagining that you would literally feel your future slowing or see the universe folding like paper in front of your nose. They ask whether you could look sideways and catch time standing still. They picture light itself as something you could sidle up beside and compare notes with. These images are charming. They are also how the boundary gets turned into nonsense. The real story is harder to cartoon and richer to inhabit. It concerns measurements, signals, energy, directions, durations, and the fact that no observer gets to take their local experience and declare it the whole universe's preferred narration. Now think about children on Earth while your ship is away. Some are born after your departure. Some grow up hearing about the mission as a near myth. Some study your transmitted data in schools. Some become old enough to join the institutions that continue tracking your progress. If you return after extreme relativistic travel, the people waiting may not simply be the people who waved goodbye. They may be their descendants, their students, or the political and cultural inheritors of a world that changed while you remained comparatively young. You selected whose time you would share. There may be no more emotionally honest way to say it than that. Relativistic travel is an exchange rate between intimacy and reach. The farther you extend your experienced reach through the cosmos, the more intimate time with home you are likely to surrender. This does not mean the exchange is never worthwhile. It means the cost should not be disguised beneath adventure language. The stars do not become close by kindness. They become close by converting common life into geometry. At this point, maybe you wonder whether gravity changes the story. It does, but not in a way that rescues the basic premise. General relativity adds gravitational time dilation, curved space-time, and richer complications wherever strong gravity matters. Around planets, stars, and black holes, clocks can disagree not only because of relative motion but because of differing gravitational potentials. Yet the central lesson of your thought experiment survives. Even in the simpler special relativistic framing, motion alone is enough to split ordinary intuition about shared time and distance. Gravity deepens the universe's capacity for disagreement. It does not restore the old simplicity. That is helpful because it prevents one common escape hatch. Sometimes people hear about time dilation near black holes and imagine that near-light travel's weirdness might somehow be a special case caused by exotic gravity, something optional and cinematic. But your voyage does not need a black hole to become strange. Empty space plus high relative speed is enough. The cosmos does not require monsters to unsettle common sense. Geometry alone can do it. And geometry, unlike spectacle, cannot be switched off when you are tired of thinking about it. Even if the crew stops discussing philosophy, even if the mission settles into procedure, even if the window shutters stay closed against radiation and instrument glare, relativity continues. The clocks keep separating. The route ahead remains contracted in your frame. The return to Earth, if it ever happens, keeps accumulating its eventual shock. The transformed relationship between motion and measurement does not care whether you find it beautiful this week. This can make the journey feel morally lonely in another way. On Earth, many truths are socially shared. Seasons, weather, workdays, historical events, public grief, public joy. In the ship, some truths become too frame-specific to feel public in the same way. You know your own elapsed time intimately. Earth knows its own. Both are real, but they are no longer lived together. The mission becomes a separation not merely of bodies but of temporal citizenship. And still, the stars ahead keep offering themselves. This is why the premise retains its power. Even after every warning, every cost, every dismantled fantasy, the possibility of shortening an interstellar route in your own frame remains astonishing. The universe does let something dramatic happen as you approach light speed. It lets distance yield under the condition that you do not ask for the old meanings to survive untouched. It says yes, but only if you accept that space and time were never what your village instincts thought they were. That conditional yes may be more beautiful than an easier universe would have been. An easier universe might have offered simple speed without consequence, a bland openness in which distances were trivial and time was everybody's identical inheritance no matter what. Such a universe would be convenient. It would also be shallower. Our universe ties reach to causality, speed to geometry, and ambition to altered comparison. It makes travel meaningful because travel does not merely cover ground. It reorganizes relation. So if you're still asking what would happen to space and time, the answer is no longer waiting at the exact speed of light like a prize egg in a machine. It has already been happening throughout the approach. Every fraction of light speed you add deepens the divergence. Every successful push upward in velocity teaches the same lesson more severely. Space becomes less universal. Time becomes less shared. The sky becomes less innocent. Communication becomes less conversational. Arrival becomes harder to define. Return becomes more shocking. Causality becomes more obviously precious. The boundary at light speed is not where the story starts. It is where the story's trend reveals that your ordinary language can no longer keep going unchanged. This is also why the exact endpoint cannot be given to a massive traveler as a simple experiential report. If you ask what you would see, feel, and measure at light speed as a person in a ship with mass, relativity refuses, because the setup demands a rest frame for something that cannot have one. You can ask what happens as you approach the limit. You can calculate the growth of time dilation, the contraction of lengths, the energy demands, the directional shifts in radiation, the increasing operational danger. But you cannot stand exactly on the boundary as a massive observer and narrate from there. The grammar of the question has reached its own event horizon of meaning, even though this is not a black hole story. That refusal is not the universe teasing you. It is the universe preserving consistency. And consistency, if you have followed the journey honestly, turns out to be the hidden hero of the whole script. Not the ship, not the engines, not the bravery of the crew. Consistency is what makes the madness intelligible. The same structure that denies exact light-speed travel to massive objects is the structure that allows different observers to compare clocks without contradiction, signals without paradox, and journeys without collapsing cause into nonsense. What first felt like prohibition reveals itself as protection. Protection can still feel merciless when it crushes a dream, but some dreams need to be crushed into better questions. Instead of asking how it feels to arrive at light speed, you learn to ask how space-time behaves as a massive traveler approaches the limit. Instead of asking whether time stops, you ask whose elapsed time is being compared and along what path. Instead of asking whether distance is really contracted, you ask in which frame the measurement is defined. Instead of asking whether the ship becomes magical, you ask what operations remain possible under changed radiation, changed simultaneity, and changed energy cost. These are smaller, stricter questions. They also lead to real understanding. If the mission has done anything for you by now, it has made those stricter questions feel alive. And that is the best kind of scientific storytelling. Not the kind that overwhelms you with nouns, but the kind that changes what you think a good question sounds like. Near light speed, space and time do not perform tricks for spectators. They revise the rules by which spectators become participants. The cost of the lesson is that you must give up some comforting sentences. The reward is that the universe becomes far stranger and far more coherent at the same time. There is still one final human image worth carrying before the formal answer arrives. Imagine returning home and standing in a room that should feel familiar. Gravity still holds you down. Air still fills your lungs without machinery in between. A glass of water still waits on a table without restraint straps. Somewhere outside, sunlight still arrives at the same cosmic speed that denied your ship the final crossing. Yet nothing feels entirely ordinary, because you now know that the peace of the room was never the peace of a simple universe. It was the peace of a local arrangement in which space-time's deeper tensions were too gentle to notice. That room is not a smaller truth than the voyage. It is the same truth under softer conditions. And maybe that is the most intimate payoff of all. Relativity does not only transform the stars, it retroactively transforms your understanding of home. The clock on the wall is not naive because it agrees with your pulse. It is fortunate because you live in a regime where the disagreement is too small for daily life to expose. The flaw is not objectively simple. It is a surface within a frame where distance behaves quietly enough to feel absolute. Home becomes astonishing, not because it is exotic, but because it is locally merciful. Still, there is more to live through before you can honestly claim to understand what the approach to light speed does to space and time. The middle of the journey is where concepts stop feeling like lecture material and start behaving like climate. At first, relativity appears in dramatic statements. Clocks diverge, distances contract, simultaneity fractures. But if you stay with the ship long enough, those statements turn into atmosphere. They become the unquestioned background of every ordinary act. You stop reacting to them with surprise because surprise is too expensive to maintain for months or years. Instead, you adapt. The mission develops its own emotional weather. Long plateaus of procedure interrupted by brief fronts of insight, maintenance, fear, and mathematical clarity. Suppose you wake one cycle and review the overnight logs. The cabin temperature remains stable. Radiation monitors show no alarming burst. Guidance drift stayed within tolerance. A signal from Earth arrived, delayed as expected. The ship transmitted its own packet, also on schedule. None of this sounds like revelation. Yet every line in the report belongs to revelation. Temperature stability matters because waste heat and environmental exposure are relentless. Guidance matters because tiny errors do not stay tiny at interstellar scales. Communication timing matters because every timestamp is another proof that the universe is not giving you one universal present for free. Routine does not replace the cosmic lesson. Routine is how the lesson becomes survivable. This is why life aboard a relativistic ship would likely become intensely administrative. Not bureaucratic in the petty sense, but administrative in the existential one. Everything must be counted, because space-time has stopped tolerating vagueness. If a storage container is misplaced, that is not merely untidiness. It may alter shielding, distribution, or emergency access. If a clock loses calibration, that is not a small technical embarrassment. It weakens your bridge to external comparison. If a software model fails to propagate uncertainties honestly, then the ship is not merely inconvenienced. It may be lying to itself about where it is headed and when it will matter. The larger the journey, the less glamorous negligence becomes. Earthly heroism often allows for improvisation, last-minute intuition, lucky recovery. A relativistic voyage can still contain courage, but courage cannot substitute for bookkeeping. You are traveling in a regime where the universe punishes small misunderstandings by stretching them across years, across enormous distances, and across frames that no longer share simple simultaneity. There is something almost monastic about the discipline required. The ship survives not by swagger, but by consistency. And consistency, again, turns out to be a form of tenderness. Every carefully checked system is a promise to your future self. Every redundantly stored record is a promise to the civilization that might one day reconstruct the mission. Every verified correction is a promise that the destination will not become meaningless through preventable drift. The ship's ethic is not conquest. It is stewardship under altered geometry. You begin to notice that language on board changes, not because the crew becomes poetic, though maybe it does, but because ordinary verbs lose their clean edges. Wait no longer means waiting inside one public timeline, soon becomes frame sensitive. Recent depends on whose clock you mean. Home means more than a place because it also means a rate of time you no longer share. Even distance starts requiring quiet qualifiers in the back of the mind. Distance by whose measure, under which simultaneity convention, in relation to which path. This linguistic erosion is not a literary flourish. It is cognitive adaptation. Humans depend on compressed speech. We survive by using small words as containers for rich habits of expectation. Relativity breaks some of those containers open. A highly trained crew can keep working because procedure replaces some of the lost intuitive compression. But inwardly, everyone aboard knows that many Earth-made shortcuts of thought have expired. The mission teaches an unfamiliar modesty. Before speaking casually, ask whether the sentence still means one thing in all the frames that matter. There would be practical consequences even in the way you teach children about the mission back home. If the civilization remains invested in the ship across generations, schools would have to explain why the travelers are not merely far away, but also differently accumulated in time. Public imagination would resist. Some people would simplify the story into myth. The crew went to the future. Others would simplify it the other way. It is just an illusion of clocks. Both would miss the substance. The real explanation would have to walk a narrow path between sensation and pedantry. It would have to say, with enough patience to survive public frustration, that the difference is not imaginary and not magical. It is geometric, measurable, and paid for by motion. The farther the ship goes, the more the mission becomes a cultural mirror. Whatever a civilization believes about time, memory, sacrifice, and connection gets forced into view. A society that worships conquest may celebrate the voyage while quietly ignoring the human cost of divergent time. A society more suspicious of heroic narratives may treat the same voyage as abandonment disguised as progress. Some communities may imagine the crew as saints of knowledge. Others may think of them as people who exchanged common life for a severe kind of solitude. Relativity does not decide which culture is wiser. It merely removes the option of pretending the trade is non-existent. Meanwhile, on board, the crew keeps living in bodies. This deserves repetition because abstraction is seductive. You are not a point mass in a derivation. You are a metabolizing animal inside an engineered refuge. You get hungry. You misplace tools. You develop rituals. You become irritated by recurring noises. You crave weather without having any use for it. You learn which corners of the habitat feel psychologically wider. You might begin talking to delayed recordings in a way that would feel embarrassing on Earth and essential in transit. The contrast between the ship's local human scale and the universe's external relativistic scale may be the single most surreal part of the entire experience. A toothbrush drifts slightly from where you left it. A maintenance hatch refuses to seat cleanly the first time. Someone jokes about stale food. Outside, your frame is assigning a contracted distance to the route ahead while Earth is aging through more of its history than you are. The mind does not like to carry both scales at once, so it alternates. It thinks domestically for a while, cosmically for a while, then feels briefly sick when the two touch. That sickness is philosophical, but it also has operational consequences. A crew that cannot emotionally integrate the meaning of the voyage may become careless in one of two ways. It may trivialize the strangeness and start treating relativistic effects as if they were just rhetorical decorations on ordinary travel, or it may become so haunted by the scale of the trade that local tasks lose urgency. Good mission design would need to protect against both errors. The crew must neither domesticate the physics into banality nor mythologize it into paralysis. Perhaps this is why the ship's calendar would matter so much. A self-consistent onboard calendar does not restore shared time with Earth, but it protects social life inside the habitat. Meals, sleep periods, maintenance windows, exercise blocks, communications review, psychological care, observatory sessions, all of it depends on the crew agreeing to one local rhythm. Relativity can fracture cosmic simultaneity without being allowed to fracture the social metabolism of the people on board. The ship must manufacture continuity even while the universe withholds universality. That continuity would be a kind of defiance. Not defiance of physics, defiance of dissolution. You cannot command Earth to age at your rate. You cannot demand that distant events line up with your preferences, but you can insist that inside this bounded habitat, for as long as the systems hold, breakfast follows waking, maintenance follows breakfast, and people remain answerable to one another in a coherent day. Relativity rearranges large-scale comparison. It does not relieve you of small-scale obligations. Now consider what the stars themselves mean to you over time. Before launch, stars are destinations, symbols, old companions of the night sky. During the mission, they become data sources, directional hazards, calibration targets, and reminders that the window can no longer be trusted in ordinary ways. Near light speed, the meaning of a star depends not only on where it is, but on how your motion transforms the light it sends. The universe becomes less like scenery and more like a negotiated signal environment. You may begin to miss darkness, not because space is bright in any crude sense, but because scientific awareness can ruin innocence. On Earth, the night sky often feels like depth. In a relativistic mission, the sky ahead becomes work. The light from certain directions matters as energy, not merely as beauty. The instrument package reads where danger concentrates. The crew learns that blackness is not absence but structured exposure. The romance survives, perhaps, but it has been educated out of its childish version. This is another way the voyage transforms space. On Earth, space often means room, openness, possibility. Near light speed, space becomes more tactical. Forward space is compressed, energized, and less forgiving. Rearward space is dimmed and stretched. Lateral directions are not simply left and right in a neutral arena. They are parts of an observational geometry, distorted by your motion. The word space stops naming emptiness and starts naming a pattern of transformed relations. Time undergoes a similar demotion from abstraction to logistics. People on Earth talk about time as though it were either a philosophical mystery or a scheduling inconvenience. On the ship, it becomes infrastructure. Clocks are not symbols. They are load-bearing elements in the interpretation of your life. If your timekeeping fails, your relation to Earth becomes harder to reconstruct. Your science degrades. Your navigation becomes more error-prone, and the mission's very meaning can blur. Timekeeping is not a measurement laid over reality. In a relativistic mission, it is part of how reality is responsibly inhabited. This makes the clocks almost ceremonial. You imagine a crew member pausing for a moment longer than required while reviewing the comparison between onboard time and transmitted Earth time. Not because the numbers are surprising anymore, but because they remain solemn. Each discrepancy is a materialized truth about separation. Each validated drift is proof that the mission continues to trade shared history for subjective reach. In another kind of story, a clock is just a prop. Here it is, one of the main characters, and yet, for all this gravity, there would still be laughter. There has to be. Humans do not carry unbearable truths without modifying them socially. Someone would make jokes about relativistic Monday feeling suspiciously similar to ordinary Monday. Someone would give affectionate nicknames to calibration routines. Someone would complain that if simultaneity is relative, then perhaps a missed chore should also be relative. Humor would not trivialize the mission, it would oxygenate it. Humor also performs an epistemic function. When people joke carefully about a hard truth, they often prove they have integrated it better than people who can only recite it solemnly. A crew able to laugh about the absurdity of maintaining pantry inventories while their civilization's history outruns their own is not necessarily disrespecting the voyage. It may be demonstrating the only healthy way to metabolize it. Reverence without relief becomes brittle. Near light speed, brittle minds are dangerous. Still, some nights the relief would fail. You would lie awake and think about the fact that every minute you experience now does not correspond to one uncomplicated minute for Earth. You would picture parents aging, children becoming adults, governments rising and falling, storms crossing oceans, languages shifting at home, all while your own local time continues at its steady interior pace. Even if you knew the equations before launch, there is a difference between understanding them in the classroom and feeling them after years in transit. Knowledge acquired abstractly can become grief when embodied. The ship, then, is not just a physics laboratory, it is a grief machine. That sounds harsher than I mean it, but not by much. A relativistic human mission would force new forms of mourning. You would mourn events before hearing about them because you know history is accumulating faster behind you. You would mourn futures you can already infer you will not share at the same rate. You might even mourn your own eventual return, if return means entering a world in which your psychological continuity no longer matches anybody else's memory of the mission's beginning. And yet the same voyage would also be a generator of wonder so intense that grief alone cannot summarize it. To move through a universe that finally reveals the non-absolute character of distance and duration is not merely tragic, it is intellectually sublime. You are learning, by participation, what the structure of reality demands when motion becomes extreme. Many people would consider that worth almost any personal cost. Many others would not. Both reactions are human. Neither can erase the physics. Suppose the mission approaches a target system successfully enough to make deceleration meaningful. Now the entire geometry of concern begins to rotate. What was once the forward hazard remains dangerous, but the mission's emotional focus changes from enduring the route to preserving usefulness at the destination. Speeds that once felt like triumph start feeling like momentum you urgently need to shed. Instruments that were tuned to long transit may need retasking for local science. The crew's psychological horizon narrows from abstract years to concrete operations. Strangely, this can make time feel more ordinary again inside the ship, even as its discrepancy with Earth remains vast. Approach is where ambition cashes out. You finally discover whether the voyage created presence or merely passage. If the ship can slow enough to inhabit the system rather than spear through it, the contracted route of your frame becomes something more than a mathematical convenience. It becomes a usable human encounter with elsewhere. But if braking proves insufficient, then the entire philosophy of the mission must be re-evaluated. Was the goal always to witness briefly? To send data home before vanishing onward? To prove access rather than residency? Near light speed forces clarity on motives because the cost of ambiguity is too high. This is also where local time recovers some of its primitive authority. During a close approach, procedure becomes immediate again. Burn timing, instrument windows, navigation corrections, hazard avoidance, observational priorities, contingency responses. Earth may still be too delayed to manage anything in real time, but the crew's own moments suddenly matter in the old way. One missed window is one missed window. One mistake is not philosophically interesting. It is operationally fatal or expensive. Relativity has not disappeared. It has simply been joined by the sharpness of local consequence. And then, if the mission is designed for return, the most merciless chapter begins. Because return does not restore what departure cost, it reveals it. You can imagine this before launch. You cannot know it before launch. Knowing, in the human sense, arrives only when the numbers on the clocks correspond to faces altered beyond your emotional predictions. Return means discovering whether the home you preserved in language can survive contact with the home that continued without you. It means testing whether identity can bridge a temporal asymmetry that was mathematically expected and personally impossible to rehearse fully. The scene is almost unbearable to picture with enough honesty. You disembark, perhaps unsteady under a gravity that should be familiar. The air feels ordinary and therefore miraculous. People greet you with reverence, curiosity, pity, joy, projection. Their culture has had longer to change than your body has had to age. Their references may not quite be yours. Their sense of the mission may belong to history, legend, or inherited national mythology. For you, departure may still feel like one continuous life. For them, it may be ancestral memory made flesh. This is where time's relational nature becomes morally undeniable. All those years spent explaining that time dilation is not an illusion find their full human proof here. The difference between your elapsed years and Earth's elapsed years is not hidden in equations anymore. It stands in altered architecture, different politics, new accents, unfamiliar grief, changed institutions, absent names. The clocks were always telling the truth. Return is what truth looks like when it grows a face. What, then, has happened to space by the end of the full journey? Not only has space contracted along your outbound and inbound route in the frames relevant to your motion, it has also been reclassified in your imagination. The cosmos is no longer divided simply into near and far, home and elsewhere. It is divided into places reachable within one pattern of shared life, and places reachable only by accepting altered coexistence. Relativity does not eliminate far. It multiplies what far can mean. Likewise, what has happened to time by the journey's end? Time has revealed itself not as a single river carrying everyone uniformly, but as a property of world lines, environments, and comparisons. The lesson is no longer academic. You have lived one rate of accumulated experience while Earth lived another. Neither was fake. Neither could be reduced to the other without destroying something important. Time has become both more fragmented and more real than the old intuition allowed. There is also a political implication hiding here. A civilization that seriously contemplates relativistic travel would have to reconsider law, responsibility, representation, and memory under conditions where travelers and stay-at-homes do not accumulate time together. What does consent mean for missions whose social consequences will be borne by descendants? How are promises kept across asymmetric durations? How do institutions remain accountable to people who may return personally, continuous but historically displaced? Physics does not answer these questions, but it creates them unavoidably. This means relativity is not just a challenge for engineering and philosophy, it is a challenge for governance. Any society mature enough to send humans near light speed would need ethical frameworks as advanced as its propulsion systems. Otherwise, it would build the machinery to distort shared time without building the wisdom to absorb the result. The crew would not merely be travelers, they would be citizens departing one temporal order and re-entering another. The mission architecture would have to include not just shielding and fuel, but cultural foresight. And if that sounds too grand, remember that even ordinary travel has always reorganized human obligation. Ships, railways, aircraft, digital communication, all of them changed what counted as near, urgent, reachable, and socially connected. Relativistic travel would do the same at a more severe scale. It would be history's most powerful machine for turning distance into altered relationship rather than simple separation. Space and time would change not only in physics textbooks, but in law, memory, family, and political identity. This broadening of consequence is another reason the title deserves a long answer. If you ask only what happens to space and time in the equation book, the answer is concise. If you ask what happens to them in a humanly inhabited universe, the answer expands. Contracted lengths and dilated durations are not sterile facts. They propagate into communication, return, grief, wonder, ethics, architecture, scheduling, language, and the very definition of what it means to remain part of one civilization while traveling at a rate that prevents ordinary coexistence. The ship, by now, has become an argument you can live inside. It argues that local normalcy and global strangeness are not enemies. It argues that causality can remain intact, while simultaneity does not remain shared. It argues that engineering and philosophy are not rival ways of thinking when a mission depends on both. It argues that precision is not the enemy of poetry, because the real poetry of relativity lies in the exactness with which it unsettles intuition. And perhaps most importantly, it argues that limits can be revelatory without being punitive. To say you cannot reach exact light speed as a massive traveler is not merely to slam a door, it is to illuminate the hallway leading up to the door with more richness than you expected. The approach contains enough wonder, danger, and conceptual upheaval to occupy a civilization for centuries. The impossibility of the endpoint does not make the neighborhood trivial. It makes the neighborhood the real subject. That is easy to forget because human imagination is addicted to thresholds. We love the summit, the finish line, the exact moment of crossing. But the universe often hides its deepest education in asymptotes, in limits you approach and never occupy. Near light speed is one of those educations. It forces you to learn from the trend, not the arrival. The more carefully you approach, the more the structure reveals itself. The final refusal is part of the revelation, not a subtraction from it. If you needed one sentence to carry through the rest of the mission, maybe it would be this: relativistic travel does not make space disappear or time stop. It makes both of them stop belonging to naive common sense. Everything you have experienced on board is a variation on that theme. The contracted route does not erase space. It reframes it. The divergent clocks do not destroy time. They expose its dependence on path and frame. The altered sky does not falsify vision. It shows that observation is tied to motion more intimately than everyday life reveals. The impossible final crossing does not reduce the value of the attempt. It clarifies the terms under which reality can be crossed coherently at all. By the time the ship's story is complete, you may no longer envy the fantasy of exact light speed. Why would you? The fantasy wanted a dramatic stunt. The real voyage gave you a universe in which geometry governs intimacy, speed reshapes coexistence, and the ordinary room you once ignored becomes newly miraculous, because you now know what had to remain gentle for it to feel ordinary. That is not less astonishing than a clean breakthrough. It is more adult, more difficult, and more faithful to the world. So when people ask, perhaps casually, perhaps after seeing a headline or a diagram, what would happen to space and time if we could reach light speed, you now know why the answer must start with a correction and continue with a journey. The correction is that a massive human traveler cannot simply reach exact light speed and file a diary from there. The journey is everything that happens as you approach that limit honestly. The deepening split between local and distant time, the contraction of the route in your frame, the altered radiation environment, the collapse of simple simultaneity, the transformed meaning of communication, the emotional exchange rate between reach and shared life, the possibility that return will prove the mathematics in human terms more painfully than any classroom ever could, and the revelation that space-time was one thing all along, merely hidden beneath low-speed mercy. By now, even the simplest objects in the cabin have changed their meaning. A cup is not just a cup. It is routine preserved against cosmic dislocation. A clock is not just a clock. It is a witness. A wall is not just a wall. It is the boundary between a fragile local normalcy and an external environment your velocity has made less forgiving. A message is not just language. It is a delayed bridge between incompatible presents. The mission has taught you to read symbolism out of function and function out of symbolism. That may be the deepest transformation of all. Physics began by changing what the universe meant. It ended by changing what objects mean inside your hands. There is still one more dimension of the voyage worth honoring, because without it, the story remains too clean. Uncertainty. Even the most carefully designed relativistic mission would not proceed through a universe fully known in advance. Interstellar space is sparse, but sparse does not mean perfectly mapped. Engineering models can be exquisite and still incomplete. Materials behave well until some rare combination of stress, heat, radiation, and time reveals a weakness nobody had to confront before. Detectors can tell you much and still leave you arguing over what matters most. A crew approaching light speed would not merely be enacting theory, it would also be discovering where theory, instrumentation, and reality still require negotiation. That discovery would produce a special kind of humility. On Earth, uncertainty often feels local. You wonder whether rain will begin in an hour or 3. You wonder whether a machine can keep running another month. You wonder whether a signal dropout is noise or failure. In a relativistic mission, uncertainty stretches with consequence. A doubtful reading about shielding degradation is not only a maintenance concern, it may alter whether the next phase of acceleration remains responsible. An ambiguous navigation solution is not only a mathematical irritant, it may decide whether your contracted route still intersects the future position of the system you hope to enter. This is why scientific caution would not be optional rhetoric aboard the ship. The crew could not afford to speak with the kind of false certainty that popular summaries sometimes reward. They would need a living taxonomy of confidence. This reading is strong. That extrapolation is provisional. This environmental model is robust in one range and weak in another. This system margin is comfortable under expected conditions but fragile under compounding failures. Relativity already teaches that frames compare differently. Mission life would add another lesson. Knowledge itself comes with gradients that responsible people must speak aloud. That practice would shape personality. You can imagine a crew gradually becoming less impressed by certainty and more impressed by calibration. Who makes the cleanest estimate under incomplete information? Who distinguishes clearly between what the instruments measured and what the model inferred? Who resists the temptation to give a dramatic answer when only a conditional one is deserved? These traits sound academic on Earth. Near light speed, they become forms of courage. In that sense, the mission would select for a new kind of hero. Not the reckless genius who improvises against impossible odds. At least not most of the time. More often, the hero would be the person who notices an assumption early, tests it honestly, explains the result without ego, and prevents the ship from building grand decisions atop small misunderstandings. The mythology of exploration may prefer the singular visionary. Relativistic survival would prefer disciplined interpreters. This matters because the title question itself can be answered badly by people who love grandness more than clarity. They may say that time would nearly stop and leave the sentence hanging as if that were the deepest insight. Or they may say that space would compress into nothing and move on before asking in whose frame that phrase is meaningful. Or they may promise that the stars ahead would become a spectacular tunnel without admitting that operational hazards matter more than cinematic expectations. The long voyage teaches patience with these simplifications. It teaches you that reality is better than slogans if you let it keep its qualifiers. Qualifiers are not weakness here. They are architecture. For example, if someone asks whether radiation would definitely kill you before arrival, an honest answer must depend on mission design, shielding, route, exposure profile, and what counts as killing first in a chain of interacting failures. If someone asks whether you would age less than people on Earth, the answer is yes in the comparative sense after the relevant journey, but that answer only becomes meaningful when you specify the path. If someone asks whether exact light speed is reachable for a massive ship, the answer is no under special relativity. But that no opens into a rich landscape of near-light consequences rather than empty negation. Every important statement arrives attached to conditions. Pull them off, and the statement becomes cheaper than the universe deserves. Perhaps that is why the mission's science team would spend so much time on definitions. Not pedantic definitions, but moral ones. What counts as a system failure? What counts as mission success? What counts as acceptable uncertainty before a burn? What counts as evidence that a detector has drifted? What counts as arrival for a vehicle that may still be moving too fast for settlement, but slow enough for serious observation? Definitions are where values hide inside technical work. Near light speed, the hiding places become too dangerous to ignore. You would feel this most sharply during moments of apparent calm. A stable week can be more unnerving than an obvious emergency, because calm invites the mind to widen again. During emergencies, action narrows attention. During calm, perspective returns, and with it the full scale of what the ship is actually doing. You may sit strapped near a window or a display, holding an object so ordinary it should not deserve reflection, and suddenly understand that your civilization launched a pocket of breathable normalcy into a regime where neither distance nor duration behaves as your ancestors imagined. Calm gives the cosmos room to become frightening again. Yet calm also gives it room to become legible. Somewhere during those long quiet intervals, the crew might stop thinking of relativity as a list of bizarre effects and start understanding it as an ethic of comparison. No observer gets everything. Every observer gets something real. Translation across frames requires care. Signals carry limits as well as information. Causality is precious because it keeps the whole enterprise narratable. These are scientific truths, but they also begin to sound like advice for living with other minds. Perhaps that is not accidental. Physics at its deepest often turns out to be a schooling in humility toward perspectives other than your own. The ship would, in that sense, be a school for civilization. Whatever it discovered among the stars, it would also return a harder lesson about how knowledge works. It would show that local experience can be fully valid without being universally sufficient. It would show that the most dangerous misunderstandings arise when people mistake their convenient frame for the frame reality has secretly chosen as official. It would show that communication delay does not just slow conversation. It changes responsibility, planning, and empathy. A society that truly absorbed the mission's lessons might become wiser even if it never launched a second relativistic voyage. But perhaps it would launch one anyway. Human beings are not cured of longing by understanding. If anything, good understanding often deepens longing by giving it more accurate form. After the first mission, the question would no longer be the childish one. Can we break the speed of light by sheer force? It would become the adult series of questions. How close is worth approaching under what cost? For what destination? With what kind of crew? Accepting what kind of temporal separation? And aiming at what kind of return? The dream would survive. It would simply become more exacting. And exacting dreams may be the only kind worth trusting at this scale. A cheap dream says that the universe is basically simple and merely awaiting enough confidence. An exacting dream says the universe is coherent, difficult, and not obliged to flatter our first intuitions. The first kind of dream produces slogans. The second produces starships, if starships are ever produced at all. Near light speed belongs to the second category. It is not a realm entered by bravado alone. It is a realm approached through honesty, patience, mathematics, materials, care, and a willingness to let wonder survive correction. Now imagine a private ritual the crew keeps near the mission's midpoint. Perhaps once every long interval, each person records 2 messages. One is meant for the present crew, to be heard soon, while faces are still familiar and local jokes still land. The other is meant for whoever exists at home by the time the message becomes culturally relevant. The gap between those 2 intended audiences says everything. One message belongs to companionship within one habitat and one onboard rhythm. The other belongs to a civilization that may receive the words as inheritance rather than conversation. Time has forked the audience. That fork is another answer to the title. What happens to time? It becomes plural in practice. Not metaphysically plural, not a mystical spray of different universes, but plural in the concrete sense that one mission now has several valid chronologies attached to it. The crew's chronology, Earth's chronology. The chronology reconstructed later by historians from signals crossing years of delay. The chronology operationally relevant to the destination system if arrival occurs. These are not fantasies layered on top of one true clock. They are structured ways the same events are ordered and measured under different legitimate conditions. And what happens to space under that same pressure? Space also becomes plural in use. There is the mapped distance from Earth before launch, the contracted route in the ship's frame during cruise, the operational geometry of shielding and exposure, the navigational geometry of hitting not where a target was seen but where it will be, the local geometry of a destination system if braking succeeds. Space stops being one homogeneous arena and becomes a family of relations that different observers, systems, and goals care about differently. The result is not chaos, it is sophistication. That is important because many people first encounter relativity as if it were an assault on reality's stability. In truth, it is a refinement of reality's stability. The laws remain coherent precisely because the old simplifications are surrendered where they no longer hold. What feels like conceptual loss at the level of intuition is actually conceptual gain at the level of structure. The universe becomes harder to summarize and easier to trust. Trust is not a word often associated with near-light travel, but it should be. The crew must trust their instruments, but not blindly. Earth must trust the crew's autonomy, but not lazily. Later generations must trust the records, the models, and the translations across frames enough to understand what happened without flattening it into myth. In every direction, trust depends on disciplined honesty. Relativity does not erode trust. It raises the standard for earning it. There may come a moment, late in the mission, when you realize the ship has taught you to love limits differently. Before launch, a limit sounded like defeat. After years inside the voyage, a limit can sound like shape. The fact that exact light speed is inaccessible to a massive traveler no longer feels like a petty prohibition. It feels like the clean edge of a coherent world. Without such edges, the rest of the story would fray. Signals could stop respecting cause. Measurements could stop translating meaningfully. The universe might become easier to fantasize about and harder to inhabit. The limit protects inhabitability even as it denies a particular dream. That is why the title's hypothetical, "if we could," needs to be handled with love rather than literalism. Love, here, means refusing to give the audience a false toy when the real answer is better. It means saying, we cannot take a human ship with mass to exact light speed and ask it for a diary from the endpoint, but we can approach the boundary in thought. And in doing so, we can discover something profound about every clock, every mile, every message, every goodbye, every return, and every assumption about the present that seemed harmless at low speed. The better story is not the breach. It is the revelation. And revelation, if it is real, should change the room you are sitting in now. The chair under you is part of a frame in which distances are almost embarrassingly well behaved. The breath in your lungs belongs to a world where atmospheric shielding and ordinary velocities spare you from noticing how violent radiation can become under transformed motion. The person you text or call later tonight shares your present well enough that the delay feels trivial and simultaneity feels almost absolute. None of these mercies are universal. They are local gifts of a low-speed life. A relativistic voyage does not make those gifts less valuable. It makes them visible. So when the final answer comes, it is not only about the far ship, It is about the near room as well. Near light speed, space and time reveal their deeper form. At home, that deeper form hides behind convenience. The same universe is present in both scenes. One scene whispers it. The other forces you to listen. Before that answer arrives, hold on to one last image from the ship. You are standing in the quiet interval after a systems review. Nothing urgent is failing. The cabin hum is stable. The walls have become familiar enough that you no longer think of them as miracle technology every waking moment. On a display, a set of clocks remains visible. Ship time, reference comparisons, transmission histories, predictive models. None of the numbers are dramatic by themselves, yet together they represent the most intimate possible proof that the world is larger than intuition and stricter than fantasy. You reach toward the display, not to change anything, but almost as if to reassure yourself that the abstraction is real. This is what the mission has done to you. It has made numbers tactile. It has taken concepts usually trapped in lectures and installed them in the same mental space as air filters, sleeping compartments, soreness in your back, the taste of reheated food, and the ache of missing someone whose presence you no longer share cleanly. Space and time are no longer topics. They are conditions of your morning. There is a dignity in that transformation. It means the voyage has succeeded even before any destination verdict, because it has forced reality out of the realm of slogans and into the realm of lived relation. You now know, not as a spectator but as a participant, that a clock is not a universal referee, that distance is not one thing for all observers, that light is not merely illumination but structure, and that causality is not an abstract philosophical preference, but the thread holding the mission's story together. And once you know that, some old fantasies become impossible to enjoy in quite the same way. The childish version of ultimate speed promised escape without cost. It suggested that with enough power, enough daring, enough engineering brilliance, you could outrun distance while keeping all the emotional and conceptual comforts of home intact. But the real universe is not interested in such bargains. It allows astonishing reach only by changing what reach means. It allows dramatic asymmetry only by making the asymmetry measurable and morally consequential. It lets you come close to a limit only by teaching you why the limit is there. That is not cruelty. It is depth. A shallow universe would be easier to fantasize about. It would also be less worth understanding. Our universe makes the same act, motion, reverberate through clocks, signals, radiation, geometry, engineering, and human relationship all at once. The price of that richness is that no honest answer to the title can remain simple for long. The reward is that even an unreachable exact endpoint becomes a lantern for everything leading up to it. So when you hear light speed now, perhaps you no longer imagine only a number. You imagine a structure. You imagine every message delayed into a different kind of truth. You imagine the route ahead shortening in one frame while home keeps its longer accounting. You imagine the forward sky becoming a harder place to look and a more dangerous place to go. You imagine the return, if there is one, proving the theory not by chalkboard elegance but by changed faces and accumulated history. You imagine home itself becoming newly precious because you have learned what kinds of agreement had to remain locally intact for home to feel ordinary at all. This is the final refinement of the question. It is not really asking only about speed. It is asking what reality reveals when velocity becomes large enough to expose the scaffolding beneath everyday life. And the answer is not that space vanishes or time dies. The answer is that both stop masquerading as absolute backgrounds and begin showing themselves as relational, structured, and inseparable in ways daily life lets you ignore. There is one last consequence hidden inside that realization. The universe becomes harder to summarize and easier to love. At low speed, we enjoy the luxury of useful simplifications. We say now, here, later, farther, the same time, the same distance, and most of the time the world lets us get away with it. Those shortcuts are not lies in ordinary life. They are kindnesses. But near light speed, kindness gives way to structure. The old shortcuts stop carrying enough truth. In their place arrives something more demanding and more beautiful. A universe in which relation matters as much as substance, in which comparison is not secondary to reality but part of reality's responsible description. That is why the journey does not only teach physics, it teaches restraint. It teaches you not to rush past conditions, not to strip a statement of the frame that makes it meaningful, not to confuse local experience with universal authority, and not to treat an unreachable boundary as though it invalidates the profound territory leading up to it. If you learn those habits here, inside a ship pushing toward the fastest regime a massive traveler can meaningfully approach, you have learned something that remains true long after the engines fall silent. And perhaps that is the hidden generosity of the whole scenario. You asked about the farthest speed because it seemed like the most extreme case. The universe answered by making the ordinary case strange as well. After a journey like this, even an uneventful afternoon on Earth carries a faint afterglow of revelation. A shared present no longer looks trivial. A familiar distance no longer looks absolute. The speed of light no longer sounds like only a ceiling. It sounds like one of the deepest clues we were ever given about what the world is. It sounds, at last, less like a barrier and more like a confession. It confesses that reality was stranger than comfort allowed you to notice. So, the final answer to the title question has two parts, and both matter. If you could travel arbitrarily close to light speed, space would contract along your direction of motion, the sky would crowd and brighten ahead of you, and the empty medium between stars would become a far more violent place than its name suggests. Time would separate between you and the people you left behind, with your own clock continuing normally for you, while Earth accumulated much more duration between the same broad milestones. Simultaneity would stop being shared. Distance would stop being universal. The universe would reveal that space-time, not space alone or time alone, is the real stage. If you ask about exact light speed for a massive human traveler, the answer changes from strange consequences to a broken premise. Special relativity does not allow the ship to arrive at that state and file a report from inside it. The closer you get, the more dramatic the effects become, but the endpoint itself is not part of the human itinerary, and maybe that is the most unsettling part. You began this journey hoping speed would make the universe simpler, go fast enough, and perhaps distance gives up. Perhaps time becomes a problem for other people. Perhaps the stars finally feel close. Instead, speed exposed the cost of closeness. It showed you that every shortcut has to be paid for in altered measurement, altered radiation, altered causality, altered agreement about what counts as now. The universe did not place space over here and time over there and ask you to choose which one mattered more. It tied them together so tightly that pushing one hard enough would distort your understanding of the other. Back in your room, none of this is visible. The air reaches your lungs without a life support system. The distance across the floor does not depend on your frame of reference in any way that matters to your legs. The clock on the wall and the clock in your bloodstream keep roughly the same human bargain. Light from the lamp is just light, not a boundary condition for causality. That ordinary piece is what relativity steals from you first and gives back last. Near light speed, space is no longer just the way to somewhere, and time is no longer just what it takes to get there. They become the thing you are traveling through, the thing measuring you back, and the thing that refuses, at the final limit, to let a massive traveler pretend they were ever separate.